Okay, Trig, chapter 3 review. I'm going through the answers here. Do not watch this video until you've at least attempted the majority of these questions, because otherwise it's not going to do anything for you to get ready for the test tomorrow. So, yeah, I'm giving you the answers, but make sure you know how to do these problems, all right? We, on Friday, when I gave you this review, went over a couple problems, and I think maybe Kelsey was the only one not here. So what I'm going to do is we're going to skip down to like number 5, and we're going to start at number 5, and then I'll come back at the end of the video for Kelsey. So you guys can quit watching at a certain point, and then I'll continue on for Kelsey and whoever else was gone on Friday that needs this. So example 5, or number 5, says use the graph of this function, and then they want us to find the maximum and minimums. They want us to find a bunch of other stuff. Okay, so I went ahead and graphed this on Desmos, and this is what it looks like. This is a x to the 4th power function, and they want maxes and mins for part A. So we have 1 maximum and 2 minimums, so I'm just going to label those over here. We have a max at, and I'm just going to list his coordinates points. So -1 and 10.5 is where he is located. Okay, Desmos marks these out really nice for us. If I just hit the point, it will give us the exact. And then we have mins at -4, -30, and 2, -30. -4, -30, and at 2, -30. And those are my maxes and mins. Okay, part B says determine the intervals on which the function is increasing and decreasing. Okay, so I'm going to do increasing here, decreasing here. We're going to write those in interval notation. And the first thing that it's doing from left to right is from here until he gets to this point, he's decreasing. Okay, and we only look at the x coordinates. We don't care about the y's in that at that point. So from -infinity until he gets to -4, he's decreasing. Okay, and then he's turning around and he's increasing from -4 to -1. All right, so increasing from -4 to -1. Then he turns around and he's decreasing again from -1 to +2. So I'm going to do union -1 to +2. And then he's increasing again from +2 to infinity all the way through there. Okay, +2 to infinity. And we're just looking at the x coordinates, not caring about the y coordinates. So there's kind of how that works. All right, moving on to part C, estimate the intervals on which the function is concave up and concave down. So first things, I'm going to get rid of some stuff here. First things first, we need to look at what he's doing first. So is he holding water or is he not holding water? So he's holding water from here until he gets to about this halfway point. And I don't know where that halfway point is at. Maybe like, let me get rid of that again. Maybe like, I don't know where this is. This right here is -3. Okay, so maybe like -2.7 or something like that. -2.7 comma -10. That's where he is located. And let's go, I'm going to go ahead and graph this point over here. This point is at 0.7, let's say, comma -10. All right, so there's those two guys. All right, so first thing he's doing is he is holding water from here to here. So from -infinity until he gets to about -2.7, that's where he's holding water. Okay, and if you're wondering how I got this number, it's about halfway in between this guy and this guy. Okay, is where that's located at. All right, so from -infinity to -2.7, he's concave up. From -infinity to -2.7, he's concave up. Then he's going to cave downward. Okay, he's shedding water in that case from here until he gets to about here. Okay, and that is from -2.7 to +0.7-ish. Okay, as long as you're close on those, I don't care. And then the last thing he's doing is here, he is caving up again, and that's going from 0.7 to infinity. So unioned 0.7 to infinity, he's caving up again. Okay, and then when it says talking about points of inflection, I call those POIs. And those are the places where he switches from concave up to concave down. So like this point here and this point here. Okay, and we just kind of approximated those. So -2.7 comma -10 is where he switches from concave up to concave down, or vice versa. Okay, now the places where he switches from increasing to decreasing and vice versa, that is at the maxes and mins. Like right here, he's switching from decreasing to increasing. Maximum, minimum, those guys. So the maxes and mins kind of go with increasing and decreasing. The concave up, concave down goes with the points of inflection. That's kind of how that works, okay? All right, let's go down to example 7. We did example 6 together, so I'll go back through with that for Kelsey. Example 7, draw the function or draw the graph of a function that satisfies each of these 4 conditions, okay? Now, I don't care what he looks like. Yours probably is going to look different than somebody else's, but it just has to satisfy these things. So it says the domain is -3 to 4. Okay, domain is talking about the x's. So the farthest to the left that he goes is -3. The farthest to the right that he goes is +4, okay? Let's go over here to range. Range means the farthest up that he goes is -2, and the farthest down that he goes is +5. Okay, or wait a second, other way around. Blah, 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 blah. The farthest up that he goes is 5. The farthest down that he goes is -2. There we go. Let's fix that, okay? So that's kind of what my graph is looking like. We've got to do some stuff in there, okay? So I'm going to go over here, and I'm going to actually start to graph this function. And I'm going to look at this thing right here. This thing says if the x-coordinate is -2, the y-coordinate is 0. So the x-coordinate is -2, the y-coordinate is 0. There's that, okay? And then it says f of 1 is greater than 2. So like f of 1, that means if the x-coordinate is 1, the y-coordinate has to be something bigger than 2. Like let's say, I don't know, let's say 3, okay? Whatever, doesn't matter. If the x-coordinate is 1, the y-coordinate we're going to say is 3. That's something bigger than 2, right? So that works, okay? So all we have to have happen is that it has to go through those 2 points, and the furthest left that he goes is -3. The furthest right that he goes is 4. So I am at -2 here. So let's say -3 is this guy right here. Let's do that. And then the furthest right that he goes is 5. 1, 2, 3, 4, 5, okay? Oh, shoot. The furthest down that he goes is -2. So let's do this. 5, -2. We're going to do that. And then we're going to go up here, and instead of putting this dot, we're just kind of playing around with this. Let's put this dot at -3, 5 right here. Okay, so let's do something that looks like this, okay? All right, so let's look at domain and range. Domain is the x's, and the x's, the furthest to the left that he goes is at -3. The furthest to the right that he goes is 4. Wait a second. I went over too far. 4 we're going to do right here. There we go. That's what he's going to look like. Okay, furthest to the left he goes is -3. Furthest to the right he goes is 4. And then we've got the furthest up that he goes is 5, and the furthest down that he goes is -2. And then he's touching here, and he's touching there, okay? So that's one example of what you could have done. It doesn't really matter. These endpoints don't have to be there. Maybe you put them down here and up here instead, and you get a function that looks like this. I don't care, as long as he's fulfilling all of those things, okay? All right, 8, 9, 10, 11, 12, all of those are going to have to do with your brochure chart, okay? So this is going to be helpful to look at that. Determine the vertex, y-intercept, and x-intercept if any of the quadratic functions. So 2x minus 4 squared minus 6. The vertex, this is really easy to identify, is at +4, -6 is where he is. The y-intercept we find by plugging 0 in for x. So if I plug 0 in here, 0 minus 4 is -4 squared is 16, and 2 times 16 is 32 minus 6. Holy cow, that's going to be a y-intercept of like 20, I don't know, 26. Something like that is the y-intercept. Okay, the x-intercept, we plug 0 in for y. Just set it there, that's fine. Oh, okay, hold on, I'll help you here in a second. The x-intercept, we plug 0 in for y, so I'm going to do that over here. 0 equals 2 parentheses x minus 4 squared, and then we have -6. Okay, we add the 6 over, so plus 6, 6 equals 2, x minus 4 squared, divide by 2, 3 equals x minus 4 squared, and then we take the square root. So we're going to have a square root of 3, which is going to be kind of ugly, but that's okay. Plus minus square root of 3 equals x minus 4, and then we add the 4 over. So I have 4 plus and minus. the square root of 3. Those are going to be my two x-intercepts. Okay, so they're crossing, but they're just crossing at really ugly decimal places. Okay, now this one is in standard form. We didn't say that over here. This is in vertex form. This guy's in standard form. Okay, and we want to find the vertex, so we do negative b over 2a. Negative b over 2a. My b value is negative 4, so it would be negative 4 or positive 4 over 2 times 2. 4 over 4 is 1, so the vertex is 1 comma something, and we've got to figure out what this something is. So we are going to, let's see, we're going to, we're going to plug it back in. 2 times 1 squared minus 4 times 1 minus 3. This will just be 2 minus 4 minus 3, and that is like negative 5. So the vertex is at 1 and negative 5, okay? The y-intercept, we plug 0 in for x, and if we plug 0 in for x, we have 2 times 0 squared minus 4 times 0 minus 3, and the y-intercept is just going to be negative 3. Okay, the x-intercept, we're going to plug 0 in for y, and we try to solve this function here. Okay, and this is a complex trinomial, except when you try to break it down, I don't think he factors out nicely. I don't think he factors out nicely. So we are going to use the quadratic formula on him. Okay, yep, that's what we're going to do. So I'm going to erase some stuff. You might need a separate sheet of paper to do these couple examples. So negative b would be positive 4 plus and minus the square root of b squared is 16 minus 4 times a times c, and all over 2 times a. So we've got 4 plus and minus the square root of, this is 16, negative 4 times 2 times negative 3 is positive 24. And that is the square root of 40 all over 4. And we can probably reduce that, but I'm just going to leave it. Okay, so that is my x-intercepts, those two decimal places, is what he will look like. Okay, number 10, determine the vertex, the y-intercept, and the x-intercept. And I'm going to do the x-intercepts first because that's easy to identify here. If I plug 0 in for x and divide the negative 2 over, that doesn't do anything. My x's will be negative 1 and positive 3. And I get that by, I'm not going to write it as an ordered pair. I'm going to say x equals negative 1 and x equals 3. X equals 3, and there's that, okay? By setting those two equal to 0, that's how I find that, okay? Now, we know, we wrote this on our brochure sheet, that if I have negative 1 and 3 are my x-intercepts, negative 1, positive 3, that my vertex has to be somewhere exactly in between those two, okay? And exactly in between negative 1 and positive 3 is at 1. So my vertex has to be at 1 comma something, okay? And to find that something, I just plug him in. So if I plug 1 in here and 1 in here, I would get negative 2 times 2 times negative 2. That's lots of 2's. And that's going to be at positive 8. And then last thing for the y-intercept, I plug 0 in for x. So I'm going to plug 0 in here, 0 in here, and I get negative 2 times 1 times negative 3, which is positive 6. And that's my y-intercept, okay? You might need to go through those 3 problems again, just because there's a lot of information that we're putting down there. Okay, these next ones should be a little bit more straightforward and not as much work. Okay, so part A, they want us to write this in standard form, so basically just foiling everything out. Okay, first thing I'm going to do is, first thing I'm going to do is take x minus 4 and I'm going to square it. Okay, so x squared. Minus 4x, minus another 4x, and then plus 16, which is x squared minus 8x. Minus 8x plus 16, okay? That's what this guy comes out to be. Then we're going to distribute a 2 through and subtract a 6. So 2x squared minus 16x, and then 2 times 16, this would be 32, but then we're going to subtract the 6 from that, so it's going to be plus 26, and that's what he will look like in standard form. Okay? Next one, part B, we're going to FOIL these two and then distribute the negative 2 through, and then we'll be done. So x squared minus 3x plus 1x minus 3. So x squared minus 2x minus 3. And then if we multiply everything through by a negative 2, we get negative 2x squared plus 4x plus 6. And that's what he will look like in standard form. Okay, so not terrible. A little bit of work yet, but anyway. All right, list the transformations they say on this one. We're starting with x squared, and then we have to decide what's happening. So x squared, we have this minus 3 that's happening. We have this plus 4 that's happening. Then we have the negative, okay? And remember, I'm going to do part 8 over here. Remember that of those 3 things, it does kind of matter what order you go in. So remember that, like, if you're plugging an x in, like, what would you do to it first? So I would subtract the 3 first, which is making him go to the right 3. Then I would apply the negative, which means he's going over the x-axis, and then the plus 4 is moving him up 4, okay? So that's kind of what part A is doing. Part B, we have same amount of things happening. So there's a 5 happening, there's a minus 1 happening, there's a 1/2 happening. So 1, 2, 3, we've got to decide what is happening first. Okay, if I plug an x in, this 5 is going to happen first. And since that 5 is inside of the parentheses, it's going to be a horizontal, and in this case, it's going to be a compression by 1/5, okay, because you have to flip the sign, all right? Minus 1 is moving him to the right 1 unit, and this 1/2 is a vertical compression by 1/2. That's what that is going to look like. Okay, so that was kind of ugly with the stretches and compressions, but that's kind of how that works, okay? All right, 13 says determine algebraically whether the graph has is symmetric with respect to the x-axis, y-axis, origin, okay? So this is another thing that we wrote down on our brochure thing. Okay, x-axis, y-axis, origin. We're going to do that just in the same headings as they have there, okay? X-axis means that we're plugging a negative in for y. Y-axis means we're plugging a negative in for x, and origin means negative x and negative y is what we're plugging in, okay? So negative is going in for the y, so we have 5 times negative y equals 7x squared minus 2x, and we're going to look at this thing, and we are going to just get rid of any parentheses that we have. So here, this would change to minus 5y, and that's all the more simplifying that I can do. So we look at that and we say, did that change back to the original? No, because this minus is still there, so this one would be a no for x-axis, okay? Y-axis, the more you do these, the easier it is to probably do some of this stuff in your head. Like 5y equals 7 times, if I take a negative x and I square it, it's just going to become x squared, right? And if I take this negative x, it's going to multiply by that negative 2, this guy right here, to become a positive 2x, positive 2x, okay? So now I look at that thing, and I say, is that the same thing as the original? Well, it has 5y, it has 7x squared, but it has plus 2x instead of minus 2x, so that's also a no, okay? And then I do the same thing again for origin. I have a negative y here, which is going to make that negative 5y. I have a negative x here, which is going to switch back to just 7x squared because the square makes it positive. And then I have a negative x here, which is going to become positive 2x. So is that the same thing as what it was before? Let's see. 5y became a negative 5y, 7x squared. Nope, that's still a no. So this one has none of those symmetries. None of those symmetries. Now, one really big hint. If you have this solved for y, if you would divide by 5 on everything and you would get y equals this stuff, you could plug that into your calculator and see whether it has x-axis, y-axis, or origin symmetry to check your answer. That would be a really good idea, okay? All right, now I'm not going to go through all the steps here, but I'm just going to tell you what each one of these is for x-axis, y-axis, origin. X-axis is going to be a no. Y-axis is going to be a yes, and origin is going to be a no. Okay, so that's kind of how that one boils down to part B. I'm not going to write out all the work for that, but there's that. okay? Number 14 says determine whether the functions from problem 13 are even, odd, or neither. Okay, so it's even if it has y-axis symmetry. It's odd if it has origin symmetry, okay? So since part A had none or had no symmetry, it was a neither function, okay? But part B had y-axis symmetry, so it would be an even function. So that's kind of how that works out, okay? All right, 15. Oh, heavens to Betsy, we got lots of stuff going on here. All right, so we have two polynomial functions that we're adding together to start with. So we have 3x plus 2 plus x cubed plus 1, and then we just combine like terms and put them in order. So x to the third is going to come first, plus 3x plus 3, and that's all you can do with that one. Okay, second one, f minus g, so we've got 3x plus 2, but then we're subtracting, and I'm going to put this second guy in parentheses because we have to distribute the negative. So this would really be minus x to the third minus 1. So we've got negative x to the third plus the 3x is going to go next, and then plus 1. That's what he will look like. Okay, f times g, we're going to FOIL this guy. Let me write him out first. Okay, we're going to FOIL, so 3x to the fourth plus 3x plus 2x to the third plus 2. That's what he will look like FOILed. And then I'm just going to put them in order. So 3x to the fourth plus 2x to the third plus 3x plus 2. That's what he will look like. Lots of stuff. All right. F divided by g. We have, let's see, 3x plus 2 over x to the third plus 1. Okay, and then it says determine the domain. Well, two things that screw up domain is a negative inside of a square root and dividing by 0. Okay, this one I don't want this number to be 0. So I can literally say x cubed plus 1 cannot be 0, and then I just solve for x. So if I subtract the 1 over, x to the third cannot be negative 1, and if I take the cubic root of negative 1 is saying, what do you take times itself 3 times to get negative 1? And it is negative 1, so x can't be negative 1 in that case. All right, so E and F go together kind of, and G and H kind of go together. G and H, you're plugging in numbers. E and F, you're plugging in actual functions. So let's do that. So here, you're plugging G into F. Okay, so I'm taking this thing and plugging it into F here. So 3x plus 2, but instead of the x, I'm doing x cubed plus 1. So that comes out to be 3x cubed plus 3 plus 2, which would be plus 5. I'm adding some stuff together in my head here. Okay, next one, we're plugging f into g. So this guy is going in here, and it is x to the third plus 1. But I'm going to plug that in there, and I'm going to be lazy and not FOIL that cubic thing out, okay? If you did, good for you. If not, great. We're not going to do it because we're in another room. So there's that. We're just going to leave it, okay? This one, we have actual numbers to plug in, so we're going to find g of 2 first, and then we're going to plug that number into f. So g, I got too many things circled here. G is this function here. We've got 2 to the third plus 1. 2 to the third power is 8. 8 plus 1 is 9. Okay, then we're going to find f of 9. We're plugging that into the f function. So that's 3 times 9 plus 2. 3 times 9 is 27, plus 2 is 29. So when you plug a number in like this, you're going to get a number out. When you're plugging just an expression in, you're going to get an expression out. Okay? All right, negative 1. We're going to plug negative 1 into f first, so f of negative 1. And that's 3 times negative 1 plus 2. And this is negative 3 plus 2, which is negative 1. So now, that's kind of a coincidence. We're taking g of negative 1 now. And this is negative 1 to the third plus 1. Negative 1 to the third is negative 1 plus 1 is 0. There he is. Okay? All right, we're getting closer. 16, find the inverse, the 4 steps of finding an inverse. First, you switch the f of x to y, then we switch the x and y. So we've got x equals the square root of y minus 3 plus 4. And now we're just unwinding it and solving for the y here. So we're going to subtract the 4. And we get x minus 4 equals the square root of y minus 3 to get rid of a square root, we square it. So this is now gone, and then I'm going to add the 3 to that side. So y will be equal to x minus 4 squared plus 3. And I can switch his name and call him f inverse of x to make him look better. That's what he will look like as an inverse function. Let me write it over here. F inverse of x. I'll write him pretty. X minus 4 squared plus 3. There he is, right there. Okay? All right. 17, determine by composition whether those two functions are inverses of each other. So when they say composition, Marcus, they're saying f composed of g of x, do that side, and then also do g composed of f of x, like that, okay? So there's how that works. So here we're plugging g into f, okay? And so that guy, this guy goes in there. So we've got 4 times 0.25x plus 1.5, and then minus 6, okay? We're going to distribute the 4 through. 4 times 0.25 is 1x, plus 4 times 1.5 is 6, minus 6 equals x. That's what we want to have happen, all right? Next, we're going to plug f into g. So this 4x minus 6, I've got too much going on here. 4x minus 6 is going to go into this function here. So 0.25 times 4x minus 6, and then plus 1.5. All right, so now let's distribute that 0.25. So 0.25 times 4 is 1x, and 0.25 times 6 is negative 1.5, and then plus 1.5. Those two are going to cancel out, so I just get x again. So that tells me, yes, they're inverses. Yes, inverses. Okay? All right, a couple more. 18, determine whether or not this function has an inverse function. All right, his parent function is x to the 4th power, and we know that no matter what, an x to the 4th power function looks something like a w, and a function has an inverse function if it passes the horizontal line test. Not the vertical line test, the horizontal line test. So we have to decide, does he pass the horizontal line test? No. His inverse is not a function. Okay? All right, that was pretty easy. 19, the graph of a function below consists of straight line segments. Find an overall, or find an interval over which the average rate of change, another word for that is slope. Find where the slope is 0. Slope is 0 right here. So we can say, there's a couple of different ways you could write it out. This is 2 and this is 5. So we can say the slope of 0 when you have, not equal to, we're not going to say equal to, where x is greater than 2 or less than 5, or you could just say from 2 to 5 parentheses. That is where your function has a slope of 0. Okay, so either way you want to write it, I don't care. I'm going to write the rest of them like this. Okay, from 2 to 5, that's where we have a slope of 0. Okay, slope of 2/3, meaning I'm going up 2 and over 3. Up 2 over 3 from, I don't know if that dot is supposed to be over here or not. He kind of looks like he is. I'm going to assume that this dot is like over here in the corner, even though he doesn't quite look like that. So over here, this dot is going up 2 over 3, up 2 over 3. So we're going to say that between this point and this point, he has a slope of 2/3. So that would be from like -6 to 0. We'll say something like that, okay? If you didn't say that and you just said like from, I don't know, let's say -3 to 0, that's fine. On the test, if there's a questionable call about whether that dot is over here, I'll always give you the benefit of the doubt, okay? Last one, the slope is -3. Looking on this little chunk, that's only a slope of down 2 over 1, so that's just a slope of -2. But from here to here, that's down 3 over 1. So it would be just between this point and this point, from 1 to 2, he has a slope of -3. Okay, last thing, the profit of a function is represented by this equation. Find the average rate of change, which is the slope. And they're wanting the slope from 4 to 5 tons. Okay, so I would start by writing out 4 comma something and 5 comma something. And we plug them in and we see what we get for a y coordinate. All right, give me a second. 0.2 times 4 squared plus 0.5 times 4 and minus 1, minus 1, and we get 4.2. Okay, now I plug 5 in, and 5, and I get 6.5. Okay, all right, now these guys are represented, these guys were represented as tons, and the profit is represented in hundreds of dollars. I'm almost done, so you're fine. I'm almost done. All right, so slope is y2 minus y1, so 6.5 minus 4.2 over 5 minus 4. 6.5 minus 4.2 is going to be 2.3. I could have done that maybe in my head. Oh yeah, I could have done that in my head. Whatever. 2.3 over 1. And 2.3 over 1 is just 2.3, but since we're in hundreds of dollars, we have to move the decimal 2 places, like times 100. So this would be $230 per ton is what that would look like, okay? Whew, that was a lot. All right, so there is the review. Hopefully you did okay on that, and you're prepared and ready to go for the test tomorrow. As always, the tests are usually a lot easier than the review, so as long as you did okay on this, you're going to be good to go, all right? But still study, you know, and make sure you're ready to go with that, okay? All right, Kelsey, going back to the top, 1 through 5. Number 1, what is the domain of this function here? And you can't really see him because my stuff's in the way. So here, we're looking at domain for each one of these, and then we have this function and this function. Okay, the two things that screw up domain are division by 0 and a negative inside of the square root. So this one is typically easier than this one to do. So let's start with number 2 first. Here we look at this and we say, what can x not be equal, or what can t in this case not be equal to? And we say t can't be 6 because if I plug 6 in, I would end up getting 0, and that's bad. Okay, here, when you're trying to solve this one where you have a negative inside a square root, it's easier to set it equal to 0 on the inside. So I say negative x plus 3, this chunk is equal to 0, and we solved for 3, and then I put 3 on a number line. And if we put 3 on a number line, we say that like numbers larger than 3 don't work, and numbers less than 3 do work. So we would say in that case that x, the domain is x is less than or equal to 3, and that's what that looks like, okay? All right, next, down here, number 3, the cost of renting a limo, and we're talking about the cost for 20 and the cost for 30, and we just look at this chunk to figure out which function it goes into. So 20 is going to be a number that's between, gosh dang it, a number that's between 0 and 25, so 20 would go into this top function, it would just be 150. Versus 30 is a number that's greater than 25, so we would plug 30 in here, and we got 202.50. And that's how that works. And then it says, what is the domain of this function? This chunk over here on this side tells me what I'm allowed to plug in. And one thing we noticed was that we are not allowed to plug in numbers that are less than 0 or equal to 0 because it's missing the equal to sign. So we just say the domain is strictly numbers that are greater than 0. Okay. Number 4. What's the domain of the function? The x's are going, the furthest left he goes is -4, the furthest right he goes is 5. So you can write it as this or this, I don't care. Okay. Range is up and down. The furthest down he goes is -3. The furthest up he goes was, we said, like 3.5 or something like that. So you can write your answer like that or like that. Doesn't matter, okay? Part C says, if the x-coordinate is 1, what is the y-coordinate? So we go over to 1, and the y-coordinate is down here at -3. So that's the answer to that. Part D, f of -1 is saying if the x-coordinate's -1, the y-coordinate's 0. Plus f of 3. If the x-coordinate's 3, the y-coordinate is like we said 1.5. So we add those two together and we get 1.5, and that is all, okay? Last one is number 6. And number 6 is determine whether or not the function is a function. So this is x to the 3rd power, okay? And we said that, it doesn't really, x to the 3rd power generally does like this shape here, right? Okay, but even if he has like a little bit more of a hump to him, he's still going to pass the vertical line test no matter what. So yes, he is going to be a function. Now, you know, later on down, we talked about whether he has an inverse function, and that would matter which one he looks like. Like this one wouldn't have an inverse function because he doesn't pass the vertical line test, versus this one would, okay? But we're not asking for the inverse, we're just asking for the original, okay? So there's that, all right? That's all I have.